Today I'm going to be creating what I want to call the laptop cluster. I have a few of these older laptops that are about 10 years old now, and I'm just going to try putting them in a cluster using Proxmox and see how it goes, see how the experience works, see how it is stability-wise, see what type of performance I can get out of it, and just see how the overall experience is. The main reason I'm trying this is because laptops like this, for me, are essentially free. These are about 10-year-old laptops running Sandy Bridge and Ivy Bridge architectures. They luckily have quad cores though, so they have a reasonable amount of performance. I believe these systems have between 8 and 12 gigabytes of RAM, which is what I'd say the bare minimum for running like Proxmox or another hypervisor is. And I've added a gigabit NIC to the one that only has a 100 megabit integrated NIC, and this guy has a built-in gigabit NIC, so there's reasonable network speeds going on right now. Now one issue is I only have 2 of these reasonably fast laptops I can use right here. And Proxmox and most clusters get kind of unhappy with 2 clusters, because you have a problem that if one node dies, then you only have one node in the cluster. The way that Proxmox works with voting is it has to reach a certain number of votes to have anything happen in the cluster. And with 2 devices, that means both devices would have to agree. And if one node's offline, that can't happen because one of the nodes is offline and can't agree. So you can either set it so that one node is essentially the master and says what always happens, or you can make it so that you don't need less votes to agree, but basically both of those ruin the high availability. You can do it in a home lab setting if you need to, but the best solution is actually just get a third system that I have down here. This laptop is even older, running a Core 2 Duo system with about 2 gigs of RAM, but it's more than enough just to be that third vote in Proxmox. I don't plan on running any VMs or containers on it, and you can also use something like a Raspberry Pi for this use case. You just need enough horsepower for it to basically be the third vote. So then if either the faster systems go offline or just the third system, there's always 2 votes left, and the 2 systems can keep running as a full cluster. Now one thing you might think is, why might you want to use laptops? Well, the first reason is they're pretty easy to get your hands on. At least for me, I seem to get these fairly free from e-waste bins and other places like that, and just find them used from other people relatively easily. The next thing is, they're pretty small, low power, and you can kind of tuck them away easily. These are opened up and big right now, but I can close the lid on these, stack them in a small pile, and kind of tuck them in a corner pretty easily, and they use fairly minimal space. And also because they're designed to run off battery power, they use quite little power compared to some other systems. So all 3 of these systems together should be less than 100 watts, and probably like 30 watts, 40 watts at idle would be my guess, as laptops are typically quite good at very low idle power consumption. The other advantage is they essentially have a built-in keyboard, video, monitor, and mouse, so you don't have to add anything if you want to administer a system. And they also have a built-in battery, which essentially works as a UPS, so I can yank the power cord and the system will just keep going, so I don't need an additional UPS. But the disadvantages compared to a small form factor desktop or a full-on server is much less upgradability. A nice laptop might have 2 hard drive bays, but that's pretty rare with some newer models and smaller ones. And you're not going to get more than that like you can with a desktop or server. Relatively limited memory upgradability. This guy is fairly high-end and supports 32 gigabytes of memory, but a lot of systems from this era don't. And it can often be quite expensive to find the largest DIMMs that you need to get that 32 or 16 gigs of RAM that the laptop can support up to. Like this guy has here, a good amount of lower-end laptops put 100 megabit network cards in instead of gigabit, which really limits things like NAS uses. I'd say streaming, any type of shared storage on the network. I'd really strongly suggest you get a USB 3 to 1 gigabit NIC, as I find it works better than 100 meg, but neither are great solutions. As for software, I've just put a plain install of Proxmox VE 7.1.2 on all of these, which is just the newest version of Proxmox at this time. I chose Proxmox as it is a free hypervisor. I'm pretty comfortable with it, and it generally works quite well on fairly low power hardware like this, as it has fairly low hardware requirements itself. I've done some of the initial setup, like going through the installer, updating these systems, and doing kind of my basic setup for all Proxmox systems. I talk a little bit more about that in my Proxmox setup guide a few videos ago if you want to see more details. So now I've gotten the 3 laptops pulled up on my computer screen here. I have them open in the browser and in a terminal with SSH, and they look like normal blank Proxmox nodes. Nothing has been set up. I gave them all their own host names and IP addresses. So let's go take a look at creating that cluster. So I'm going to take a look at my first node here and just create a cluster. And let's call it the Lappy. and it's going to start creating the cluster right now, and I've created it. So now I can see the join information here, which I want to copy and paste into my other systems, and that way they can become part of the cluster. Proxmox is in general pretty easy when it comes to setting up clusters. So now my cluster is being created. Looking in the web GUI, the biggest change on the left is now I see my 2 other laptops here, and I can see and manage all of those settings just like if I was on their web page. So the easiest thing a cluster lets you do is manage it as if it was one system. Also, I can look in the command line with PVE-CM status, and it shows me my 3 systems I'm running here. The fact that they're all votes are happy here, shows all the systems, shows how many votes they have, and everything is working correctly in this cluster. So now let's take a look at creating a VM. So I've uploaded an ISO of OpenSUSE on here, and now I can see my multiple nodes that I can put it on. I can call it like OpenSUSE1, and then I can just create the VM like I normally would be able to on a node. So nothing really special creating this VM on here. Now the one thing is when I'm creating the VM, I can still only see storage and other devices on the local system. So just because I have the cluster and I can see all the systems doesn't mean I can use the storage or any of the resources from the other systems by default. And it essentially just lets me manage the other systems. So now I've installed a few VMs on my cluster, and let's play around with running them on different systems. So I have a Ubuntu VM that's currently shut down, and I have a Windows 10 VM that's doing what Windows 10 loves to do and updating. So I'm going to take the shutdown Ubuntu VM, and now I can actually migrate it to other systems. So I can pick a different node in the system. So let's do laptop 2, or this guy, my Ivy Bridge quad core. And it says it has a relatively large disk, so it might take a while. And with migrating between the systems, it'll copy the VM configuration, so all the details of how the VM's made. And then it'll also copy the disk image. And that's what's going to take a while. So if I look at my screen here, it's about a gig out of 32 gigs down, copying that 32 gigabyte VM image to the other system. And this isn't limited to being done on shutdown systems. I can also do this on a running system here. So it might take a while. It also warns me that, and it also migrate my running VM. But actually, when doing this, I got a little bit of an error here, which is saying that it can't move it due to missing instructions. So one of the things in Proxmox that's basically ignored, at least by me, if you're running a single node, is the type of CPU you're running. So if you go under memory processors and then edit, by default, it'll do the KVM64, which is that, and I normally recommend just using a host with a single system. And the host is just going to copy whatever CPU your system has and just show that to the VM. But if you're migrating between multiple nodes like I'm doing here, and especially since these are different generations, with this one being a Sandy Bridge and this one being an Ivy Bridge, they support different features. So I'm going to have to normally set it to the lowest common denominator, which should be Sandy Bridge here. And let's take a look at that. So this one says it's set to Sandy Bridge, but it doesn't seem to be working because both of these are at least Sandy Bridge. So I'm going to have to take a look at why it doesn't like Sandy Bridge and what exactly it's complaining about. So it looks like with a bit of Googling, the IBRS involves some of the Spectre mitigations that will be force required if it has it. If you use the IBRS one, if you don't use it, it won't force require it. But it's still interesting. It doesn't want to migrate my one with the Sandy Bridges. I believe they should both be at least Sandy Bridge. So once this finishes, I'm going to try turning it down to just a KVM64 and see if that will migrate. And taking a look at my Ubuntu shutdown VM that's finished, it looks like it's copied all the 32 gigs of the virtual machine disk successfully, so it's on the new system. And on the left, I can see it under laptop 2. And let's just try firing it up on this guy right now. So it looks like it started, and it's throwing that same error that it can't start using that function with Sandy Bridge. So I took a little bit of a deeper look to see if I could figure out what's going on. Google didn't have an obvious answer other than just use whatever the host says in KVM, which does work. And taking a look at the CPU features, I ran a little online difference, and it looks like there's a few features like SMX, AES, and LAHF, LM that are different, that the older system has that the new one doesn't have. And I'm guessing that's the issue. I'm not sure why it isn't supported. To my knowledge, Intel didn't remove those between generations, but it might also just be due to the BIOS configuration or however Dell set the system up, as it's often that those CPU features that are disabled by either the BIOS or the system manufacturer or other things. But it does look like in this use case, setting it to KVM64 does work fine, so I'm just going to do that for right now. Firing up the console, I can see that my Ubuntu VM is working correctly on the other system, just as I'd expect. Now that I have a Proxmox cluster set up and I have migration working between my laptops, let's try to do a little bit more of clustering and try to make these systems work together a little bit more. So one way to do that in Proxmox is HA, or high availability. And the idea behind it is if one of these laptops was to die, it'll keep running my VMs on another system. Now it's not perfect because it shuts down the VM when one of the systems dies and then the other one fires it up in a little bit, but it's still pretty good and doesn't really require any special software. You just have to have it start up when the VM restarts. But the problem with this and my current configuration is since I'm using local storage on both of these laptops, if this system were to go down, all of its VM data and VM disks would now be inaccessible to the other systems to boot from. So there's a few ways to get around that. The easiest way in Proxmox is with replication. So I'm going to take a look at an example system I have replication set up with here. And replication essentially just copies the data from one VM on one system to another VM on another system. By default, it's every 15 minutes. So the worst case scenario is you have an image that's 15 minutes old if it was to fail. And it'll also use ZFS send and receive under the hood to make this work. So looking at my system, I have VM 103 right now, which is my Windows Server 2019 system set up to have replication. If I take a look under data center replication, I can see that it's on laptop 1, but it's being replicated to laptop 2 every 15 minutes. So if I look at my data I'm storing on here, I can see that I have my VM 103 disk on the host that it's running off of, which makes sense. And I also have it on the other host that doesn't have the VM. And that way, if this guy dies, it already has the data essentially on here, maybe a little bit old, and can just restart it on here. So that's pretty simple, works pretty well. And if I was to fail a system, it'll just keep working that way. Now the other way to do it is to have shared storage. And the idea behind this is you have some sort of storage system that all the computers in the cluster, like all these laptops, can access at the same time and everyone can see it, unlike local storage where only that system can see it. There's a few ways to do that, like having a separate NAS or SAN that everyone can access, but I already have 3 laptops here, so I don't want to set up more than that. So what I'd want to do is try to make it so that each of these laptops has an additional drive in it, and it uses that drive to share storage. And in Proxmox, Ceph is the best way to set that up. I am not an expert in Ceph and really don't know that much, but Proxmox is pretty plug and play, and I probably made one of the worst setups you can create. Both of these laptops have an extra SSD in it, and I just said create a Ceph OSD with that in there. And taking a look at my cluster right now, if I look at Ceph on my systems, I can see that I have 2 nodes in my Ceph. Both of the OSDs are working correctly, and it says it's really degraded. And my guess is this is due to it wanting to have 3 copies of all my data, but I only have 2 systems that can store it, so it only has 2 copies. I believe this is editable somewhere, but I can't find it right now, so it's going to stay in this mode. It does mean if one of these systems were to go down, it will keep it running. Now, one thing I was curious about when setting up this Ceph configuration was how performance is going to be like. Because compared to a traditional single internal drive, Ceph has a lot more going on. It has 2 systems it has to talk to, it has to go over the network, there's just a lot more happening. So I installed a VM on Ceph and ran the most basic disk benchmark with Crystal Disk Mark on Windows. 150-ish megabytes per second read, 44 write, and those random writes are really bad. And my guess is that's because it has to confirm the write with the second system and go over the network every time there's a write. That's pretty slow. And I really don't know how exactly to speed up. Faster networking would do it. You might be able to have it so one local drive confirms it and then it writes it out later to some sort of caching solution. I'm not sure, but I believe that a commercial, a correctly set up Ceph can do it. Now the question is this enough performance? And if you're just playing around, it kind of is. So I'm on Windows 10, I'm just going to fire up Edge, for example. It takes a little bit longer than I expect, but it's kind of between hard drive and SSD in most uses. I'd say this is usable for light use, but I probably wouldn't want to push it too hard. Another thing I did to take a look at Ceph performance was using the GNOME Disk Benchmark tool. So taking a look at it here, I can see those speeds popping up really high, likely due to RAM cache, and then going down as probably the RAM cache isn't used as much. Latency is 0.2 milliseconds average, but I can see some spikes in a couple of milliseconds. And the write speeds are pretty crummy, just as Crystal Disk Mark showed here. It's usable, but this was one of the longest Windows installs I've done when this guy was installing. So I'd say barely usable, and this is 2 SSDs on 2 old laptops. If you set it up correctly, Ceph can be very fast, but this is not a correct Ceph setup. I'd probably stay away from using Ceph like this on these old systems. While it works, it's pretty crummy and you're really pushing the limit of what you can do with Ceph. I'd probably stick to Replication if you need to have an HA solution. Now, the one big upside with Ceph and any other solution where all the systems can access the data is that migration works a lot better. So let's take a look at migration on here. So I'm going to migrate my Windows 10 VM over to the laptop system, and because it's shared storage, it doesn't have to touch the storage at all. All it has to do is copy the RAM from this system to this system, and it'll just migrate the VM. So in this case, it's super fast to migrate, only like a couple of seconds, less than a minute, whereas it would take a lot longer if it didn't have the storage copied already. So now it's almost done copying the VM state, 16 milliseconds of downtime, and I can take a look at my virtual machine, and now it's running on a different host and works just fine. The VM doesn't even notice that it got moved between hard systems. Now let's take a look at testing that high availability here and seeing how well that works. So I'm going to set up some high availability in Proxmox. I set it up for VMs 103, which is my one that's being replicated to the other system. And I'm also going to set it up for my one on Ceph storage. So that's my Windows 10 B VM. And I'm going to set it up with a group I called good ones, which is these laptops that can actually run the VMs. If you don't do it, sometimes it put it on my third laptop, which can't run the VMs, and you run into a lot of weird issues. So I'm going to add this guy to it. And then if this guy is to die, which it's going to do right now, I'm just going to go kill it. It's going to automatically, or it should, move all the VMs to this system when it detects it. Proxmox says this is a up to 2 minutes thing, but we'll see how long it actually takes. So it's detected that this laptop's dead, and now I can see that these 2 VMs, or 3 of them actually, are now running on this system now. And they had to reboot because they went offline. It did force the VMs off. You can't do it where it keeps the RAM state. But if I take a look at the console right now, it's still a functional VM. My luck on camera seems to be pretty bad. I did quite a bit of testing for this video and did mini power off cycles and just showed how everything would migrate successfully from one system to the other. But every time I seem to try to show it on camera, it doesn't work. And I think I just found a way to brick 2 VMs. My Windows 10 B VM that was stored on Ceph is now just not happy. It'll boot into like the Windows 10 logo where it has the dots, and then it just dies and restarts. And then my Windows 2019 system wasn't happy when I migrated over to the replicated disk, says it can't boot from the volume, and won't boot ever again. So I just broke 2 VMs with trying to migrate it. There might be a way to look in snapshots and get older versions of the data, and I don't know enough about Ceph to try to get this working correctly, but it just doesn't seem happy with what I've done here. Taking a little bit of a closer look at Ceph on here, Ceph was not happy to lose one of its nodes. I'm guessing Ceph is kind of like Proxmox, where it really wants 3 or more nodes. So when it's with 2 nodes and one of them dies, it's just kind of like, I don't know what to do, and it just fails. That's what it looks like. It showed it's looking a little bit better now because it detects both systems are up, but it wasn't happy with 2 systems. You want to probably have the 3rd system actually in Ceph all running, but I'm not going to get into Ceph too much more here. I've had replication work fairly well on Proxmox, just not now it seems to be. So overall, is this something I'd want to set up more for the long term or in a new setup? My answer is probably not for me personally. These laptops turned out to be a lot more of a bear in Proxmox to use than I expected. I thought this would be a pretty simple cluster to use, but I think I just found a way to keep breaking things in ways I didn't expect. I probably want to do just a full wipe on all these systems if I was to use it more, because I think I just have something weird in my configuration now that it really just doesn't seem to like. I think the other thing I've learned is don't do shared storage like Ceph on such a small system. It just really isn't happy. You gotta make sure these distributed systems are set up with a good configuration. I've tried multiple times to have a distributed storage on old systems, and it never works out well. You kind of just can't do it at a small home level like this with older systems. You need to actually throw correct hardware to get distributed storage working correctly. But if you just want to play around with clusters, this is a pretty good way to do it. These laptops are very cheap now. You can get the kind of feel for setting up clusters on real metal instead of having a cluster running in a VM. And I think it can have a lot of learning in how to set up clusters, how to handle failures and stuff like that, that you couldn't do if you just had a single node. But if you just want a simple home server or something, I'd do a single node, possibly set up 2 in Proxmox, but don't do anything fancy, just migrate VMs every once in a while if you need to. Thanks for watching this video on setting up a laptop cluster of these old systems. Let me know if you're using our cluster on old systems like this and how it's working for you.